today our notes are going to be on page 5 and 6, and they're going to be on scatter plots. So put in your table of contents 5 and 6 scatter plots. Then go to page 5, and I've already got my title here, scatter plots. So we've been doing a lot of stuff with finding measures of center and measures of variance. And we did talk about how statistics has a lot to do with graphs. And so this is our first thing getting into a graph in a way. It's a visual way, scatter plots are a visual way to see the data, okay? And so the big thing about scatter plots are that they show the relationship between data. So scatter plots show the relationship between data. Okay, and we call these trends. So you might have heard that before, like you look for trends in the data. The big thing is we're going to be having two sets of data, okay? So not just the height of the girls' track team. We're going to have things like, I think of height in my son who's in 5th grade. He's growing a lot right now, and he's also needing new shoes. So usually the taller you are, right, the bigger your shoe size is. That's what I'm talking about, where I'm comparing height and I'm comparing shoe size, and we see what the relationship is between that data. Okay? Now, the relationships, there's 3 different types of relationships, and these are called correlation. Okay? The first one is a positive correlation. So your data can have a positive correlation. You can have a negative correlation, and you can just have no correlation at all. Okay, and I'm going to show you what each of these looks like on a graph. So a scatter plot is what we think of a graph, and it's just a whole bunch of random dots. Okay, so if it is a positive correlation, you're going to have these dots scattered about, thus the word scatter plot. But they are going to be going uphill. If you remember back to last semester, we talked about slope. If I drew a line through these, they would have a positive slope. It's going uphill. Negative correlations are going to be these scattered points, these scattered dots, but they are going to be going downhill in general. Okay? Real life data rarely makes a perfect line, right? So talking about height and shoe size, you could be, I'm 5'6" and I wear a size 10 in women's shoes, but not everybody who's 5'6" wears that exact same size of shoe. So it's not this perfect, everybody is exactly the same, but there's a general trend either up or down. Now, no correlation, right? This is like just literally random dots all around. They don't have any pattern at all to them. So this could be like your height and if you're wearing a red shirt, right? There's no correlation. Taller people don't wear red more or less, right? So just 2 things that aren't related at all. There's no correlation, okay? So we're going to do an example, and I have, for me, I've printed this out so that 1, I don't have to write down this whole chart, and 2, I have this graph here, okay? I've posted this on Google Classroom, so if you have a printer, feel free to print that off, okay, and cut it out and glue it in your notes like I'm doing. If you don't, guys, then I encourage you to just pause the video, okay, right now. Pause the video and write down all those numbers in the chart and draw yourself a graph on your paper, okay? So this says, create a scatter plot for the following data points and determine the type of correlation, okay? So as I look at this, let's get this over so we can see the graph. Remember This line is the x-axis, and this one going up and down is the y-axis. So I'm really only showing you the first quadrant. We're talking about just positive numbers because in real life, most numbers are positive. Again, if I talk about height, I don't have a negative height. Everybody's going to be positive numbers. Okay, now I'm going to number these, and if I look, my x's are going across the top. I go from 1 all the way to 8. Okay, the same for the y's. I go from 2 kind of to 8. So I think, let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 10 squares here, so I'm going to count by ones. If it's something different, we'll have to count by different numbers. So I'll make this be 1, 2, 3, 4, 5, 6, 7, 8, 9, and that last one would be 10. And then I'm going to do the same going up. Okay, so then each of these, right, so like this, 1, 2, these go together. So you're going to find on the x-axis, here the 1, and then on the y-axis, the 2, and you're going to put that point there. So 1 and 2. Our next one is 2, 4. So I'm going to go to the 2 on the x and the 4 on the y, and then where they meet is right there. Okay, I'm going to kind of check these off as I go because, again, so easy to mess up and miss one. 3 and 5, so I go to 3 here, I go to 5 here, and then I follow my lines up, and where do they meet? Right there. Next is 3 and 6, so I go to 3 on the x, I go up to the 6 here, I follow my lines, I put my dot. Check it off. Next I have 5 and 3, so I go to 5 on the x, 3 on the y, follow up, they mark there. 5 and 4, so I go to 5, I go to 4, follow the lines. 6 and 8, so I go to 6, I go to 8, I come up here, there's my point. 7, 7, so I find 7 on both of them, put my point. Got 8, 7, I find 8, I got 7, follow along, I'm right there. And then the last one is 8 and 8, so that's going to be right here. Okay, so create a scatter plot, check. Okay, we just had to put all those on the graph. And then determine the type of correlation. So is this positive, is it negative, or is there none? Okay, the correct answer is positive. There is a positive correlation. Now, I will say that you're kind of like, oh, but they're really spread out. I thought it was going to be no correlation. Okay, and it is spread out, but in general, these are going uphill. Like it's a really wide uphill, but in general, they're kind of going uphill. Okay, we actually, when they're going uphill but barely, we call that a weak positive. The closer together they are, almost making a perfectly straight line, that's called a strong positive correlation. And if they're a little more spread out and you're like, I'm not so sure, that's called a weak positive. So it's positive, but okay? But that one is a positive correlation. Okay, I'm going to go to the next page, and I have another paper to glue in here. Okay, so again, if you don't have access to printer, right there it all is, pause the video and write all of that down. I'm gluing mine in. Big glop of glue there. Okay, so this says create a scatter plot for the following data points, determine the type of correlation, and estimate a line of best fit. So I'll show you how to do that in a second. Okay, so this has actual information here. This is talking about different types of hawks, and then it has their the length of the whole bird in inches and their wingspan in inches. So you would think that the longer the bird, the longer its wingspan, right? So we'll see if that is the case. So again, this length, this is going to be our x values, and the wingspan is going to be our y. So this is my x-axis. So down here, I'm going to label this as the length in inches. And then this is the y-axis. So this is going to be the wingspan. Also in inches. Okay, now I don't want to count by ones on this because if you look, right, these are like, even here, 20, 21, over here, 30s, 40s. I'm not going to have that many, okay? So what I'm going to do is I am going to kind of figure out what my range is to figure out what I should count by, okay? So if I'm looking by lengths, right, what is my highest length? It is, what, 24? Minus, what's my smallest length? 16. Okay, so pretty much I need to go from 16 to 24, right? Or, I mean, I'm subtracting the opposite way, but really, I need to have at least 16 here, and I need to go to 24. If I subtract those, right, what is that? 8. So I need 8 squares. Well, how many do I have? I had 10 before. So here's the deal. If I start at 16, I can count by ones and get there. Okay? This one, my highest is, what, 46? Minus my lowest, is 31? So on this one, I need to go from 31 to 46. When I subtract that, I've got 15. I don't have 15 squares here. I only have 10. Now, if I counted by fives, I would just have like 5, 10, 15. That's all I would need. I'd have a really short graph. I'm going to count by twos, okay? Because if I have 10 squares and I count by twos, that'll give me 20 spaces and I need 15. So that's pretty close to that. So we're going to start, though, with the lowest number here. So I had 16 was my lowest. I'm just going to put it right here, 16. So we don't have to start at 0. And if we don't start at 0, what we have to do is we put this little like jagged thing that means there's a break in the graph. So normally this would be 0, and then we basically chopped part of the graph off and we've started at 16. Then I said I can count just by ones and get exactly to where I need to be. So that's what I'm going to do here. Okay, I know that I did a whole bunch of stuff here with the range. If that's confusing you, just look at what's the lowest and what's the highest numbers and start with those. Count by ones. If that doesn't work, erase it. Count by twos. If that doesn't work, erase it. Count by fives. Okay? You don't have to do all of this if that did not make sense. Okay? Next, the wingspan. So the lowest was 31. And I'm going to count by 2. So actually what I'm going to do is I'm going to start, instead of counting like 31, 33, 35, I'm going to count by, say this is 30. And again, I'm going to put this zigzag. That means there's a break in my graph. And then I'm going to count by 2. So this is going to be 32, 34, 36, 38, 40, 42, 44, 46, and that's where I needed to be. The highest number here is 46. Okay, I think of these scatter plots, the hardest part is setting up the graph. Okay, so now that we have it set up, we are just going to, like we did before, find where those points go. So I'm going to look right here. These two go together for the Cooper's hawk. Okay, so I've got 21 on the length down here, and then I've got 36 for the wingspan. So I'm going to Put right there. So that dot is the Cooper's hawk. I'm going to put a check next to it. Then I go to the crane hawk, so 21 right there. And then 41, which would be halfway between 40 and 42. So I'm going to go 21 and then halfway there. The gray hawk, I start at 18 for the length and 38 for the wingspan. Put a dot. Harris's, I start at 24 over here and 46 way up here. The roadside hawk, 16 way down here and 31. So again, 31 would be right between those. Next is broad-winged. I start at 19 and I go up to 39, which would be right between 38 and 40. The short-tailed, 17 and 35, so again right between these, 34 and 36. And then finally, the Swanson's hawk, 19 right here to 46 up here. Okay, so directions. Create a scatter plot for the following data points. Check, that's what this is. Next, determine the type of correlation. Okay, positive or negative or none. This one is going to have a positive correlation. If I drew a line going like in the general direction of these points, it's generally going this way. These 2 points are kind of off of it, but again, those would kind of be the outliers. So there's a bird that has a super long wingspan, right? This Swanson's hawk. It's way higher than the rest, okay? But in general, most of them follow along here, which means the longer they are, the longer their wings are, which makes sense. For the negative correlation, that means like one thing decreases, the other thing also is decreasing. Okay, so that's a negative correlation. So this one has positive. Check. Now the next thing says determine or estimate a line of best fit. So I'm going to give you directions on how to do that. So right here, to find the equation of the line of best fit. Okay, these are your directions right here. To find the equation, and that's really what we're doing. We're looking for the equation of a line that would go through here. Okay, we can do it by hand, and to do that, you would pick 2 points, and then we would go through all of that stuff we learned last semester of how to write the equation of a line, like y equals mx plus b, and all of those things, finding the slope and all of that. But I'm going to let you cheat and use the calculator, okay? Because that calculator finds the standard deviation and the mean and all of that stuff, but it'll also tell us the perfect line to go through these points, okay? And the reason we look for that is to predict things. So if we said this is the line that goes through, we could maybe say, hey, there's a bird that has a length of 23 inches. We could use our line to predict its wingspan, okay? So here's the steps that we're going to do, and we're going to use the calculator again. I'm going to write them out, and then I'm going to go through them on the calculator with you. So the first step is, I'm going to simplify this from those 7 steps before to just kind of 2 basic steps, okay? 1 is put your information in, and 2 is calculate the line of best fit. So first, you're going to go, just like before, you're going to go to the stat button. And it's the same thing. You're going to go to number 1, edit. And you're going to put your data and you're going to put it into L1 and L2. So that's the new thing with this one compared to standard deviation. So it's going to go in list 1 and list 2, both. Okay? But other than that, it's all the same. So if you got used to standard deviation, you'll do good with this. Then we go back to stat, and we're going to go to the calculate part. So this should sound familiar again. And then this time, instead of doing the first one, we're going to do number 5, which is, it says, this is what it looks like. I'll tell you. So this stands for linear regression, and then ax plus b. This is similar to like the equation of a line, y equals mx plus b. M is the same as a, and that's going to be your slope, and then b is the y-intercept like we learned before. Okay, so that's what we're going to do. So just a little different from before. So I'm going to walk us through, and we're going to do this with the bird information. So again, it is Graph and Calc 83 that you need. Let me try to zoom out and get the whole calculator in here, or most of it. Okay, so again, you're going to go to stat right here. Okay, we're going to do number 1, edit. I've got information from before. I'm going to clear it out. So I'm going to tap the L1. I'm going to hit clear, which is right here. And I'm going to hit enter, which is at the bottom. And that will, well, maybe clear, enter. There we go. Okay, I'm going to do in L1, I'm going to do the length. Okay, so the length. So 21, I'm just going to go straight down that column. 21, 18, 24, 16, 19, 17, and 19. I'm going to double check that I did all of those right. Okay, so that's all of the stuff for list 1. Then just scroll back up over here, tap on the first one in list 2, and then type in your other numbers. Okay, again, I'm looking off the chart that's in the notes. Okay, if you get down to the end and like see I got 19 and 46 both in row 8, like if there's one that's longer than the other, you missed a number somewhere, okay? And it'll give you an error, okay? If you don't have two things matching up, it's going to give you an error and it's not going to work. So make sure that you double check all of these numbers as well, okay? So we just enter in 2 sets of numbers now, okay? Then again, we're going to go back to stat. And we're going to go over to calculate just like we did for standard deviation. But we're going to go down to number 5 now, linear regression. Okay, so you're going to tap on that. Just like before, you don't have to type anything in, even though it's like asking you to type something in. Don't type anything, just hit enter. Okay, and right here you have, it says y equals ax plus b, and then it tells you what a is and it tells you what b is. I'm going to write this down in the notes. Okay, so I'm going to write down that it tells me y equals ax plus b, and it says a is, I'm going to round that to 1.4, and it tells me b is 11.1. Okay, what you're going to do with this is you're just going to put all of this together. So it's going to be y equals, I'm going to replace the a with the 1.4, the x plus, I'm going to replace the b with the 11.1. This is the equation of the line that would go through this. Okay? So yeah. So that's all you need to do. Okay? So again, go through list 1 and list 2, and then pick number 5 when you calculate. Okay? I'm going to do one last thing, because like what's the point of getting this line? Okay, this would be the perfect line through those numbers. The point is to do this right here. Okay? In your assignment, it's going to take it one step further, and it's going to say, like, predict the wingspan of a hawk with a length of 30 inches. Okay, so, sorry, you can't see that. We're going to predict the length or the wingspan of a hawk with a length of 30 inches. Okay, remember, wingspan was the y and the length was the x, right? So I know that x is 30. So I'm going to take this equation right here, okay, and I'm going to write y equals 1/4. I'm taking the x out plus 11.1. So I just literally took the x out and put a set parentheses. And instead of the x, I'm going to put in a 30. So I'm going to substitute 30 in instead of the x. And then if I do 1.4 times 30, do it on my calculator over here, that's 42 plus 11.1. I get that y equals 53.1 inches. Y is the wingspan. So we have used our equation to predict. It doesn't mean this will be the wingspan of that bird, but it's a good estimate, okay, based on all of our other information. So that's kind of the point of scatter plots. They relate things to each other. We can find the line that goes through them, and then we can use that line to help us predict other things, okay? That is the end of this lesson for today. So you guys have a great day. Bye, guys.